All right, section 10.2, we're going to talk about comparing two means. And I'm going to fly through this stuff pretty fast because it's basically the same thing that we did in 10.1, just with a mean instead of a proportion. So make sure that you are pausing when you need to, rewatching places where you need to, because I'm going to go pretty fast. Okay, so we're gonna look at an example. We have the heights of 10-year-old girls and then the heights of 10-year-old boys, that mean and standard deviation. And then we're gonna take independent, simple random samples of 12 girls and 8 boys. And let's talk about what that sampling distribution is gonna look like. Okay, so if both of our population distributions are normal, like if you look at these, it says can be modeled by a normal distribution, can be modeled by a normal distribution. So if that is true, then our sampling distribution is normal. If not, then we can say it is approximately normal if either both of our sample sizes are greater than 30 or one is greater than 30 and the other is normally distributed. So we have a couple options there. Okay, the mean of the sampling distribution, just like we did with our proportions, we subtract those two population means, and that's the mean of our sampling distribution. And then for standard deviation, this is the formula that we're going to be using. Okay, and then again, we have to check that 10% condition to be able to use this formula. Okay, so we'll look at an example. You can pause and read through this. All right, so what is the shape of this sampling distribution? It is normal because both population distributions are normal. They tell you that in the problem. Okay, the mean is going to be the mean of the large one, which is 27, minus the mean of the medium, which is 17. So our mean of the difference is 10 ounces. And then for the standard deviation, in this case, we don't have to check the 10% condition because we can keep filling up soda cups from this machine pretty much infinitely. So we can use this formula without checking the 10% condition because of that. Okay, and we end up with 0.205 ounces. Okay, the interpretation is just going to be like what we've been doing all year. So the difference, and again, indicate the direction of the subtraction in the sample mean amounts of liquid typically varies by, give our standard deviation of 0.2 from the true difference of 10, which is a mean of our sampling distribution. Okay. Next thing we're going to be able to do is do a confidence interval for the difference between two means. Okay, so conditions that have to be in place should look very familiar. We've seen these before. Random, okay, two independent random samples, all right, or two groups in a randomized experiment. We got to check that 10% condition. Again, not in an experiment and not if our population is essentially infinite. And then our normal large sample rule is same as it has been. Either the population distribution is normal, that would be information given to us in the problem, or the sample size is greater than 30, or we graph our sample and there's no strong skewness or outlier. So that would be like those box plots that we did before. Okay, so you can read through this example problem. Okay, so we're going to do a confidence interval. So our state plan do conclude process. So state, we're doing a 90% confidence interval, and then we are defining our two parameters. Mean 1 is for 1-bedroom apartments, and mean 2 is for 2-bedroom apartments. Then plan, we need to state the process, the procedure that we're doing. We're going to do a 2-sample T interval for the difference in means. Okay, so let's check our conditions. Random. We know that these are independent random samples. Okay, we're going to assume that 10 is less than 10% of all of the 1-bedroom and 2-bedroom apartments near campus. That's a reasonable assumption. And then our normal / large sample, our sample sizes are 10, so we would need to create a graph. In this case, they did dot plots. I showed you guys how to do box plots on the calculator. That would be what I would suggest. And we don't see any strong skewness or outliers, so we're comfortable saying that that condition is met. Okay, so for the do part, this would be the formula. So our difference plus or minus that T star critical value like we did before times the standard error. degrees of freedom in this case, because we're using a t-star and because we have two different samples, degrees of freedom can get a little tricky. So my suggestion is just use your calculator, okay? It's going to be, I'll show you the steps for it. It's going to be the two sample t interval, okay? And then you just need to write down the summary statistics. And again, it will give you this information on the screen once you find the interval. The degrees of freedom that they write down, you'll find it's like a decimal number because they're doing some math that we're not going to get into with combining those sample sizes. And then, like always, the boundaries of the interval. Okay, so here are our calculator steps. You'll see at the end there's an option where it says pooled, and they want to know like on or off on the Casio or yes or no on the TI. We're going to go with the negative there. Okay, so if you have a Casio calculator, pooled is off. If you have a TI, we're going to say no for pooled. All right, and so if I do that with this data, here are the sample mean and standard deviations that they give me. The sample sizes are 10. All right, and they calculated degrees of freedom as 17.898. Again, we're not going to get into the math behind that. Just trust the technology in this case, okay? And then, so here is the boundaries for our confidence interval. All right, and then last step, conclude. And same conclusion sentence we've been working with. So we're 90% confident that the interval from blank to blank captures and then give in context, okay? So that like pooled thing that we're talking about, we typically assume that the population variances are unequal. There's some cases that we're not going to really talk about where the population variances are equal. And that's when you would turn that pooled thing on. Basically what you need to know is don't do it, okay? Leave it off, leave it as no, don't mess with it, okay? All right, in addition to confidence intervals, we're also going to do significance tests, okay? So just like before, we did our P1 minus P2 equals 0. Now we're looking at mu1 minus mu2. So mean 1 minus mean 2 is equal to 0 as our default null hypothesis. Okay, so conditions look familiar. Exactly the same as what we just talked about, the hypothesis test, and what we've been doing since we started confidence intervals, okay? So here's your example problem. You can take a second to read through that. All right, so our hypotheses, we're going to say that there is no difference for the first one. So the mean from 2014 minus the mean from 1975 equals 0. And then our alternative is that that is not equal to 0, that there is some difference because the question did not give us a direction greater than, less than. Okay. And even though like it seems really obvious because we put 2014 and 1975, we're still going to define our parameters every single time. Okay. Conditions check. Random, we're good. Independent random samples. 10% condition, we're going to assume that those numbers are less than 10%, and those are reasonable assumptions. And then our sample sizes are both greater than 30, so we're good on the normal large sample condition. All right. Remember with significance tests, if you're doing them by hand, we would be finding some standardized test statistic. In this case, it would be T, and this would be the formula that we would use. Looks pretty simple. We know all those numbers, except, again, degrees of freedom gets a little tricky. So, again, I would suggest using your calculator, and then these are the things that you should write down for the do part, okay? The summary statistics, again, the degrees of freedom, again, this is going to be some decimal number from the calculator that we're not going to get into the math behind. The value of the test statistic, so in this case it's T, and then your p-value. All right, so here is your calculator steps. Should look very familiar to the confidence intervals. So this time we are doing the 2-sample T test instead of the 2-sample T interval. Okay, got to make sure that we are picking the correct test or procedure, I should say. All right, so again, for the do part, we're going to use the calculator. All right, I'm going to copy down these sample statistics, the standardized test statistic T, and then the p-value and degrees of freedom. All of that is on your calculator screen. All right, and for our conclusion, same rules as before. So our p-value in this case is less than alpha. So we're going to reject the null hypothesis, and we do have convincing evidence of a difference between 1975 and 2014. A note on this p-value, this is really, really small. Typically we go out like 3 decimal places, and this has got like 5 zeros. I'm okay with you writing that as approximately 0. So either the word approximately or like a squiggly equal sign that you've seen before. Or you can write it out to 8, 9 decimal places like they did, but it's not necessary. You can say approximately 0. All right, and that's it for 10.2.